Hey everybody, this is Terry Busaletti from the Conservatory of Recording Arts and Sciences, and today we are going to be looking at the Tascam console. I know for a lot of you this is an early cycle thing and you have never had your hands on any kind of recording console at all. So that's why we're going to start here with this Tascam. We're going to run signal through this so you get a general idea of what I'm talking about through the rest of this class. Now, for those of you who have never been on a console before, or any kind of console or mixing console, don't let this intimidate you. This is our Tascam 32-channel, 8-bus plus stereo left-right bus console. But whether it's 32 channels or 40 channels or 60 channels, once you know how one channel works, you pretty much know how every channel works. So it might not be as imposing as it looks. So let's start with the basics. As I said, this is a 32-channel. We have 32 input channels, 32 channels where you can plug a microphone or an instrument into and bring signal into the console. It's an 8-bus console. Again, we talked about in basic electronics class, a bus is a common signal carrying path. All right, when I say there are 8 buses in this console, there are literally 8 wires running through this console that go to output jacks on the back of the console that have cables plugged into them. The reason we have an 8-bus console in this room is because we have an 8-track multi-track recorder. Bus 1 has a cable plugged into it. The output jack of bus 1 goes to the input of track 1. All right, bus 2 goes to the input of track 2. Always remember, outputs go to inputs. Outputs never go to outputs. Inputs never go to inputs. If it's an output, it's got to go to an input. All right, and what this allows us to do, as you're going to see, is we can plug a microphone into any of these 32 channels, and we can then send it or route it to any of those 8 tracks by assigning it to the correct bus, the output of that channel to the correct bus. You can think of those 8 buses as kind of like 8 freeways. Each one has 32 on-ramps. All right. Okay, so let's go ahead and get started here. Alan is going to take that microphone and the other end of that mic cable, and he's going to pick a channel over there to plug it into. We're going to pretend that this console is in the control room of the studio, and out in the studio proper is where the musicians would be, and that's where you're going to set up your microphones, and we'll have mic panels, and we'll show you this in Studio B later on. There'll be mic panels out there that you plug your mic into. We're going to simulate that here today with the top row that has some input jacks. Go ahead and plug that in to anyone you pick. Number 3. So he is plugged into microphone source number 3 out in the studio. And those jacks are wired through the walls, etc., into the inputs of the console. Now, that's a microphone. It produces a mic level signal, millivolts, 0.001 to 0.005 volts. So that jack gets wired to the microphone input of channel 3. Each of these 32 channels has a microphone input that is designed to receive a mic level signal. All right, so the very first thing we need to do is get that mic level signal up to what we call line level. And we do that with our microphone preamp, which is this red knob at the very top here, and it's labeled mic. Again, typically on these consoles or any of these pieces of audio equipment that you see, what it says next to the control or on the switch or next to the switch is what happens when you press the switch or turn the knob. It says mic. So this is our mic pre-gain adjustment. This is how we're going to amplify that tiny mic level signal up to line level. So I'm going to have Alan speak into that microphone. And by the way, this is a dynamic front address microphone, which first of all, it doesn't require phantom power. You just have to plug it in. It works on the principle of electromagnetic induction. Sound hits that capsule. That capsule vibrates in a magnetic field. A coil of wire vibrates in a magnetic field and produces an AC current. All right. It's also what we call a close proximity mic. So he's going to have to get very close to that mic and speak into it. And he's going to just go ahead and speak into that mic while I adjust the mic pre.
Mic check, 1, 2, 3. Mic check, 1, 2, 1, 2.
And again, I am turning this up until I get
check, 1, 2,
the meter to hit right around 0 VU. All right, and there it's hitting right around 0. Now notice this is an analog console, and so that red light that's lighting up right there does not bother me one bit because that's hitting right at 0 VU. When I hit 0 VU on this analog console, I'm right at line level, or approximately 1.23 volts. And that's what every other stage in the console wants to see as the ideal or nominal level. It's also what the multi-track recorder wants to see as the nominal level, and it's what the power amps eventually want to see as the nominal level before they amplify it up to speaker level. Now, notice that I do have headroom above 0 VU on this console. So Alan, go ahead, speak a little louder for a second. Let's just see what happens.
Check. 1,
Now,
2.
no, you might
Mic
think,
check.
oh my God,
1,
he's
2.
clipping. Well,
Mic check.
not
Check,
necessarily.
check.
We do
Mic
have some
check.
headroom above 0. And so if I'm hitting at +3 or +6 on this analog console, it's not necessarily going to be a problem, all right? But I want to make sure I'm getting it up to at least right around 0 VU. And I want to tell you this is a very important step in the whole process. This is the largest voltage gain stage in the entire system, getting that tiny mic level signal up to line level. So it's very important that we take our time and get this right. Now I want to point something out. As I mentioned earlier, I said this was a close proximity front address microphone. Front address means you need to speak into the front of it. And it's close proximity, so its sensitivity is such that you need to be very close to it to get much level out of it. I want you to move the microphone further away and speak into it. And now if we look over here, look how much level we lost. All right? So you can see mic positioning is going to have a huge effect on our overall level. So in this particular situation, I could crank the mic pre up more. Go ahead, talk again.
Mic check. 1,
And yes,
2.
I got it back up,
Mic
but
check.
if we actually had this coming through the speakers right now, you would hear that this particular setting with the mic further away and the mic pre-cranked higher is going to result in a much poorer signal to noise ratio. Now again, when I say signal to noise ratio, we're literally talking about how much signal we have compared to how much noise is being mixed in with that signal. And by noise, I'm not talking about air conditioning or car riding down the street. I'm talking about electronic noise coming from the electronic circuitry itself, all right? Any piece of equipment that you use, whether it's this Tascam console, your K6s, or an SSL console, has an inherent background noise floor. And the idea is to get your signal from that microphone far enough above that that you don't even hardly notice it or notice it at all. And so if I crank this mic pre louder and louder, if you had headphones on right now, or you could hear this, you would hear that background hiss coming up in your headphones. And that is going to be part of your signal from then on. So that's not what we want. So again, how do we fix that? We move the mic a little closer, turn the mic pre down, and that's going to give us a much better signal to noise ratio. So pay attention to this very first stage. This is where it all starts. Make sure you get this first stage right, all right? Okay, we've amplified that mic level signal up to line level. The next place that signal goes, and by the way, we can look at what's happening here as we go. Again, we have a microphone plugged in, right? We've plugged that into our microphone source out there in the studio. That's come into our microphone preamp input on the console. The next place this signal goes is to this little switch on this console. And what does it say next to the switch? It says line. Now, why does it say line? Well, basically because in addition to the microphone input on each channel, this console also has a line input, which is designed to receive a signal that's already at line level, 1.23 volts. So for instance, if I had a drum machine or a keyboard or something out there in the studio that's already putting out a line level signal, you would not want to plug that into the microphone input jack or coming to the mic input, because that is set up for those very tiny mic level signals. It'd be way too much level, and you would be distorting or clipping before you even turn the gain. So in that case, I would hit the line switch, and that would switch the input of this channel from the default input, which is mic. So in other words, if I don't do anything or push any buttons, microphone is the input to the channel. But if I press line, it switches the input of that channel to that line input, and now it's receiving signal from the line input. Now, only one of those is active at a time. You have to choose either mic or line. Now, in this case, we're using the mic input, so I do not need to press that switch. I just wanted to point that out. And by the way, if I did press the line switch, and I was using a drum machine out there, the line input has a separate gain or volume control right here, all right? But again, we don't need to use that, so I'm not going to press that switch. So the next place that signal goes is down here to this large fader on the console. Now notice if you look closely, there's a large fader down here on each channel and a smaller fader up here on each channel. These are called dual path consoles, and there are 2 faders on every channel, and you'll see why here in just a second. All right, so that signal comes down here to our large fader. Now I could refer to this as the large fader, but that doesn't tell me anything at all about what I'm using this fader for in the signal flow that I'm constructing here. And we like to be able to keep track of these things, so we like to refer to these things in terms of their function. The function of this fader is it's receiving the signal from our sound source out in the studio, and when we turn it up, as you're going to see, it's going to send the signal to the multi-track recorder to be recorded. So in terms of function, we typically refer to this as our source fader. All right, so I'm going to turn this fader up to it's right at 0. All right, if you look closely here, I don't know if you can get it on the camera, but it says 0 at this position. That is called the unity gain position. All right, now I could turn this up above and it says +5, or I could turn it down and it says -5. When this fader is sitting at 0, that basically means unity gain. Unity gain means a gain of 1. So in essence, when I put this fader at this 0 position, this is another stage where I could boost the signal or cut the signal. But if I put it at 0, it's not doing either one. It's literally taking whatever voltage level I have coming from the mic pre or line input, and it's passing that right along at the very same level. All right, so it's not boosting it, it's not cutting it. This is a good starting place when you're initially adjusting levels. Now that doesn't mean you're always going to leave this there, and in a little bit I'll show you an example where you might want to adjust this differently. But for now, when you're initially setting levels, this is where you want to be to achieve what we call a balanced gain structure and a good signal to noise ratio, and also to maximize what we call usable dynamic range. Because for instance, let's say I hadn't done a good job up here, and I decided I need a more level, I'm going to turn it up right here. Well, again, if you will speak into the microphone one more time,
Check 1,
and then
2,
speak a little
check
louder.
1, 2, check 1,
Okay,
2,
so
check
again,
1, 2.
sound is not at a constant level. We have transient peaks that exceed the average level. If I crank this way up here, there's a chance that maybe in this stage I might start clipping now. So I've compromised my usable dynamic range here. Conversely, if I decide, well, I turned it up too much up there, but rather than adjust it there, I'll just turn it down here. Now, if he does get quieter, it might disappear completely, and you might not hear it very much at all. Whereas when I'm at this unity gain position, when I'm initially setting levels, this is kind of like the sweet spot in essence. All right, he can get louder, he can get softer, but it'll still be there, and it'll still be usable. All right, so I've set that to unity gain, and again, that's our source fader. The next place that signal goes is up here to our multi-track bus assignment area. So that area that we just looked at is called the input section of the console. Now we're going to look at what's called the output section of the console, where we're going to send it out to be recorded. This is the multi-track bus assignment area. And again, now we can also view that over here on our signal flow. So again, we have our mic pre, which again went to our source fader. The next place it's going to go is to the multi-track bus assignment. And this is referred to, by the way, as the channel path of the console. And the channel path consists of the input and output sections of the console. All right, so let's talk about our multi-track bus output section. This is an 8-bus console. So I have these switches. Each switch will assign that signal coming from the source fader to 2 buses, an odd and an even. All right, this one does 1, 2, 3, 4, 5, 6, and 7, and 8. All right, we can pick any track we want. We could go to 3 since we're on channel 3, so we'll keep it simple this time. So I'm going to hit the 3, 4 button. All right. Now, again, right now it's going equally to tracks 3 and 4. All right. We have this control called the track pan, and I can choose if I just want to go to track 3, I can move this all the way to the odd position, and now that signal is only going to get on bus 3. Or if I wanted to go to bus 4, I could go all the way to the even position. If I wanted to go to more than one bus, I can leave it in the middle or do what's called soft panning somewhere in between. And again, we'll talk about that in class. But for now, I want to go to just bus 3 to get the basics down here. So I'm going to turn that all the way to the odd position. All right. Now, that's going to get on that bus 3 wire. All right. and it's going to go not directly to the multi-track recorder. It's going to make one more stop along the way. Take a look over here. We have some other faders on this side of the console. Notice there are 8 of them. These are called the bus faders, all right, or group faders. And basically, there is one for each bus, and it controls the level of all the signals that are on that particular bus. So we are on bus 3, so I need to go over here to bus fader number 3 and turn that up to unity gain. That, in turn, sends the signal to the multi-track recorder, all right? Now, the bus fader will not be pictured on this signal flow diagram right now, but trust me, there is a group fader right here between the multi-track bus and the multi-track recorder. Now, when you get to the Neotech, this is going to be called the bus trim, but here right now we'll call it the bus fader, right? Because it actually is a fader. So we've turned that up, and we're sending signal to the multi-track recorder. Now, there are 2 things you need to do at the multi-track recorder in order to record this signal. You need to put it in what's known as input mode so that it can receive signal, and you need to record arm whatever track you are going to record to, all right? Now, on some multi-track recorders, that'll actually be 2 separate switches. One switch will put the track in input mode, a second switch will record on the track. On this multi-track recorder that we're using today, one switch does both. So Alan, if you could go ahead and put channel or track 3 in input and record ready by hitting that switch right below the meter on channel 3, right? And now when you speak into the microphone, if we look at the meters there, we should see some level coming in, and you see that we do have level coming in there. Now that is a digital recorder, and again, we do not have any headroom above 0 dB full-scale digital on that multi-track recorder. So notice we are not hitting 0 there, and we don't want to hit 0. And I think we're good to go. All right? Okay, so we've gotten signal to the multi-track recorder. But here's the thing. We still have no idea what it actually sounds like. And we are audio engineers. We got to listen to it, right? So now, again, that was the channel path of the console. Now we need to bring it back and listen to it. This is called the return or monitor path of the console, all right? So basically, we took a mic level signal. We amplified it up to line level with the mic pre. We sent it to the multi-track recorder as a line level signal to be recorded. That multi-track recorder puts out a line level signal. And that comes back into a third input that each of these channels has on this console. Again, it has a mic input designed to receive mic level signals, a line input designed to receive line input signals. And this console also has a third input that's specifically designed for receiving the signal coming back from the multi-track recorder. We're just going to call that the return input. I think on this console they call it tape in because this is an older console when everybody recorded to tape. But again, let's just use the generic return, or generic term, the return input, all right? Return or monitor input. It is a dedicated third jack on the back of here that you can plug a cable into. So there is literally a cable coming from the output of track 3 to the return input on channel 3 of this console, all right? That signal then basically, and let's just go ahead and look at the next. This is our return signal flow. So the output of the multitrack feeds the line input, which is also referred to in this case on this console as the return or monitor path input. And that in turn is going to feed this smaller fader up here. Now we could call this the small fader, but again, that tells me nothing about what I'm actually using the fader for. So again, we like to define these things in terms of their function. This is receiving the signal coming back or returning. So we like to call this the return fader, or you could call it the monitor fader because we're going to listen to it through our studio monitors. So I'm going to turn up my return or monitor fader, again to unity gain. And this fader by default feeds through this mix pan control to the stereo bus. This is another pan control panning between left and right of this, what we call the stereo bus, all right? So the return fader feeds the stereo mix pan, which feeds the stereo bus, left and right, all right? That in turn feeds that red fader that you see right there, which is called the stereo master fader, all right? So we're going to turn this up to unity gain. And then we have one more thing to turn up before we can actually hear this signal, and that's called the control room level, all right, which on this particular console is referred to or is labeled as studio. So Alan, go ahead and turn yourself up there as you speak into that microphone, and we should start to hear him in the studio monitors.
Check 1 2, check 1 2, mic check 1 2, mic check 1 2, 1 2 3, mic check.
Cool. All right. So that was our basic channel path and monitor path signal flow on the Tascam console. Now, there's one more thing I want to show you here today, just as a little intro. We talked about the source fader. We talked about the return fader. I mentioned the group fader, but I did not explain the function of the group fader. So let's talk about why we need that group fader in the signal path. So for instance, let's say I had multiple microphones plugged in, all right? Let's say I'm doing a recording session and I have 3 guitar amps out there. It's Eric Clapton out there in the studio. He's got 3 Fender amps, or maybe 2 Fender amps and a Marshall. I have microphones on each one of them, and I've blended those 3 microphones. And basically, that blend of those 3 microphones, I'm going to assign them all to bus 3 in this case, right? So again, that's the beauty of the multi-track bus assignment thing. Not only can you assign one signal to a bus, but you can assign multiple signals to a bus. In fact, that's actually the purpose of the multi-track bus, is it allows you to route multiple signals to the same destination, all right? So now the thing is, and I don't have 3 microphones plugged in here today, but if I turn all 3 of these up, as I add more and more signals to the same bus, sometimes the level on the bus can begin to rise, in which case you may need to make an adjustment with that group or bus fader. So instead of, and the reason I would want to do it there instead of here is because, again, once I get this balance between these set to create whatever tonality or sound that I'm looking for, rather than try to move all 3 of these and maintain that balance, that's kind of difficult because these are logarithmic in scale. So even if I moved each fader literally a ½ an inch up or down, it would change the blend that I had achieved. But if I go over here to this fader, this is turning that blend up or down. So if I'm hitting too much level over there, I could just pull this down a little bit, and that's called balancing my gain structure, maintaining a nominal level throughout my entire signal path. All right? Now, that's most of the points I wanted to cover in this first little demonstration. We're going to talk about all this stuff in more detail. But what I also want to do here is go in reverse, because when it comes to signal flow and it comes time to troubleshoot, the most important thing you need to know about anything in order to troubleshoot is how it works. So you need to know signal flow forwards and backwards. So now we're going to go backwards. What was the last thing we turned up? The control room level. So Alan, could you turn the control room level down? And what came before that? The master fader. That was fed by the return fader. I'm going to turn that down. That in turn was fed by the actual multi-track recorder. So let's unarm track 3. And that was fed by the group or bus fader. Let's turn that down. And that was fed by the multi-track bus assignment. So we can unassign everything from multi-track bus 3 and untrack pan it. And we can now also turn down our source faders and turn down our mic pre, and we are done. So that is signal flow on the console. Again, these are called dual path consoles because we have a separate channel path, which consists of the input and output section of the console, which gets the signal into the console to the multi-track recorder, and the return or monitor section, which brings signal back so that we can actually listen to it and hear it.